Welcome and good morning, good afternoon, and good evening, ladies and gentlemen. So, as this is the part 6 of our OPCUA FX webinar series, we are doing this to build awareness about OPCUA FX in a more neutral way so that the technology can be understood, and whoever are trying to understand this technology and see how it fits to their needs and adapt. We are building all the different content so that it can be helpful for you to understand it and adapt it. So, as part of these efforts, we have created and started our LinkedIn group, OPCUAFX professionals, and we keep on publishing and creating webinars and different technical content in and around OPCUA technology in this LinkedIn group, as well as all the webinars that we have presented so far are available along with a few other interesting videos on the OPCUA FX Professionals YouTube channel as well. This is a combined effort with where we have multiple companies and multiple members of OPCUA Foundation and FX group are contributing towards this platform in creating content backed up by B&R Automation and Schneider Electric, excuse me, and other member companies and BE Services, Belden, and some of the silicon vendors and so on. So, if you are interested to know more about this technology, please join the LinkedIn group, and you can get the updates on the content and new webinars and so on. In case you have something in this technology which you want to present and coordinate with us and contribute towards this effort, you are welcome to reach out to us, and we can discuss on this topic further. So, yeah, that's about the overall efforts that we're doing in increasing awareness about this OPCUAFX technology. And today's topic is on the OPCUAFX architecture, different key concepts and insights. So here we will cover high-level information modeling and high-level workflow of how the OPCUAFX connections are established, what are the different components that are involved, what are the different types of connections that are possible, and in the end, from the security standpoint, how the OPCUAFX adopts existing OPCUA security standards for the communication. So this is what we will look at. Most of the information that I'm presenting today is already a part of the OPCUA FX specification. So in fact, most of the images that I have taken for presenting and explaining today are from the specification itself, but they are in different places. So in a sequence, how I can, the best way I can present to make you understand how this works, I'm doing that, and we'll look into it. So as always, if anybody are joining for the first time, just an overview of OPCUAFX. So OPCUAFX is a new set of specifications. So these are extensions to existing OPCUA specification. So the OPCUAFX specification is focused around providing field level communication within the industrial automation domain. So for this, different information models have been designed and extended. In the upper layers, the automation component, and then different profiles related to IO, instrument, and motion have been defined, and some of them are still getting added. And as well as an offline engineering specification has been defined as well. And for the uh, bottom level, for end stations, bridges, and other network components and services, the extensions have been defined as well. So with these extensions, the OPCA communication and the information modeling can be extended further so that the communication can happen uh, between the components in the field level. So what are the different types of communications that are possible with OPCUA FX? So this is already built on existing OPCUA PubSub communication, and the OPCUA FX communication itself internally uses OPCUA PubSub. And the PubSub has two different variants. One is for mainly for IT/OT integration and cloud connectivity, where the PubSub uses the messaging protocols like MQTT, MQP, and so on. And the other variant is for a low-level, very efficient and fast cycle time-based communications. This is based on UDP and as well as raw Ethernet frames. And at a high level, these are the different types of communications that are possible. So controller to device, device to compute, and controller to compute, and as well as controller to controller, compute to compute, and device to device. For each of these communication, there are different use cases. For example, a controller to controller enables interoperability between different machines to talk to each other, where the controllers, which are lead controllers for that machine, can exchange data with another machine in a same production line, so that they can take synchronous actions. So similarly, for each of these communication scenarios, there are different use cases that it is solving. So this is a high-level overview of OPCUA FX. In case if you want to know more from the basics, you can always refer to the previous webinar recordings that we have. So, okay. So at a high level, we will look at different components that are involved in OPCUA FX communication and the high level workflow. So basically, in this specific case, we are seeing two different engineers responsible for programming a specific controller. So here, engineer A writes the user program and then generates the descriptor, and the engineer who is developing the program for controller B will import this descriptor along with other descriptors that are required for his program, and then uses that information to create connection information between A and B. So in this specific case, we are looking at controller A sending to data to controller B, and controller B consuming and understanding that data. So if there are more connections to be created on the controller A, then controller A engineer as well can import the descriptor from controller B from engineer B, and then integrate it, import it, and use that. So here the descriptors are basically describe how a specific system is there and how the data is formulated, and then different connection related aspects, and so on. So the descriptor format is again has been standardized and defined in the OPCUAFX specification. So as we are only looking at high level, we will not get into details of each of these components and workflows in this session. Of course, in future sessions, we will do a very focused sessions on each of these topics. So here you can see controller A and controller B. And then within the controller A at UAFX level, you can see some new words like automation component, and then functional entity and asset, and so on. On the controller B, you can see along with these an additional one called connection manager as well. So we will look at this in a little more detailed way in the following slides. So at a high level, this is how the workflow is. And once this is deployed, the connection manager is responsible for invoking methods to initiate and establish connection between controller A and controller B. And from there, the data exchange starts, and both controllers will start exchanging the data. And if we are looking at the information model of these components at high level, this is how it looks. The base object type, which is a base primitive type in OPCUA base specification, and we have automation component, and we have connection manager. So the automation component itself will have different types defined within it. The main important types are the functional entity type and the asset type. And on the connection manager side, it will have all the different information that it is required to create connections between multiple automation components. So it has a connection configuration set, which will have all the different connections that are required for the overall system to function. And for each connection, the connection parameters and different connection configuration values related to how the messages are structured, when they are supposed to be exchanged, and what is the transport and the security and everything else. And the different endpoint configurations will be there, because the connections are always established between the endpoints, and for each endpoint, what are the different parameters that are there, and the different communication flow configurations. So all this information is managed by connection manager, and then the automation components will respond to the request from the connection manager in establishing the connection. So little closer look at automation component. So like I said, the critical components within the automation component are assets and functional entities. So each functional entity will have identification properties for that specific functional entity, and the configuration data, and the input and output data, and as well as its own processing and state machine related to its own processing, and any different diagnostic events that are raised during its usual processing and other stages. And then the data that is captured for specific to these diagnostics events is stored in the diagnostics data. And then the assets will have hard assets, where the controller or the different modules that are part of the controller are attached to the controller, input modules and output modules and so on. And there will be soft assets in terms of different firmwares of these hardware assets and so on. Then, in addition to these, the general metadata and health status of the entire automation component, and then the offline descriptor for the automation component itself are part of the automation component. So, how the functional entities and assets are related within an automation component. Here we can see an example. Of course, there are several different types of permutations and combinations are possible here. So in this specific example, we have three functional entities and two assets. So here the uh, nested arrangement of functional entities are possible as well. So that means a functional entity can have another functional entity within itself, and the nested functional entity instance itself can have its own input data, output data, configuration data, and so on. And these functional entities, multiple functional entities can be can have references to a one asset instance, or a single functional entity can have references to multiple asset instance as well. So in terms of scalability and flexibility, this is very much useful. So with this, so all the these relationships and all the assets and functional entities will be within the automation component. So a little more detailed look at how these functional entities can be defined and customized based on the OPCUA information modeling rules. We can discuss here. So basically all the primitive functional entities, yeah, all the functional entity type itself, and as well as all the different profile specific functional entities are defined in the OPCUAFX specification. When I say that there's a IO profile and there's a motion profile and so on, so these are part of the OPCUAFX specification. And the companion specifications, again, these are again standardized information models which are built on top of OPCUA based information models. And these companion specifications are defined by several organizations, including OPC Foundation, with respect to how the OPCUA technology and information modeling can be adapted for use case specific or industry specific cases. So, for example, for packing machines, how you can define information modeling for packing machines based on OPCUA based information models is defined as a companion specification. Similarly, for different existing Ethernet based network protocols as well, companion specifications have been defined on how you can map the data from that specific protocol to a OPCUA information, OPCUA server, so that the mapping is uniform across all different implementations within the industry. So, like this, using the functional entity type and then the using any of the already standardized to profile specific functional entities as basis, you can build on top of it for specific use cases. So in this example, we can see information model for a machine function entity, and then similarly a companion specification for a drive specific functional entity, and so on. And then beyond this, the automation suppliers or different solution providers can customize this further. So either they can choose to build their functional entity type based on profile specific or the base functional entity, or they can extend a companion specification defined functional entity to further to meet their requirements. And similarly, it can be extended further by the system integrators, and even to a level where customer specific functional entities can be defined based on the specific machinery or specific use case that the customer is trying to solve. And then, as you can see, the complexity increases as and when you keep on extending it further and further. It starts with primitive functional entities defined already in the OPC UA specification. That includes the functional entity type and as well as the profile entities. And then companion specification is complex functional entities, and beyond that when it goes to application level functional entities. So in terms of designing a custom solution, yet based on a standard based functional entity is possible with this. So in terms of scalability and flexibility, and as well as keeping your unique value of your own product or solution is very much possible by using this as a base information model. So how these functional entities talk to each other. So again, at a first glance, this picture may look a little overwhelming. So we will try to break it down so that it becomes much simpler to understand. So in the OPC UA the connections are always established between functional entities, and the connections are established when a specific method called establish connections is called from the connection manager. And in any server can have only an automation component, or it can have a connection manager as well as an automation component, or it can have only connection manager as well. So all these different types of permutations and combinations are possible. So in this example, we are seeing this server with connection manager and as well as automation component, and this automation component have one functional entity. And here we are looking at a second server. It has only automation component, and it has three functional entities. And here we have a server which only has a connection manager, and here again automation components with only functional entities. And here this connection manager is responsible for establishing connection between the functional entity of automation component 1 and 2, and also a different connection between the two functional entities of the same automation component, which is automation component 2. And the connection configuration set of this connection manager is color coded in green, so that from the picture it is clear that this establish connections method call is responsible for establishing these two connections. Similarly, here this connection manager is responsible for establishing these two connections, and here this connection is between automation component 3 and 4, and then this connection is between automation component 4 and the automation component 2, where the third functional entity is connected to the automation component force functional entity. So again, this will allow you to design the system in a much flexible and autonomous way. So there can be multiple connection managers responsible for different connections. For this is again based on the use case and based on the specific tasks that are being planned as part of the overall system. You can define this very well and keep everything isolated, yet the whole system comes together and works seamlessly. So what are all the different types of connections that are possible? So here we will look at it in a little more detailed manner. So each connection endpoint in a functional entity of an automation component can have output data and input data, or it can have output data and heartbeat, or input data and heartbeat, or in some cases it can be just output data or just input data and so on. Again, this is all again completely flexible depending on the specific application. You can define exactly what inputs and outputs and heartbeats you are required. So here we are looking at a bidirectional connection where the output data from controller B is mapped to input data of automation component A, and similarly output data of automation component A is linked to or mapped to the input data of automation component B. This is a bidirectional connection where the data is being published and consumed by both automation components at the same time. And here we have a unidirectional connection with a heartbeat. So when there's nothing to share between automation component B to A, there can be a heartbeat going on just to understand that the consuming automation component B is alive, and as long as that is going on, the connection can stay alive, and then the automation component A can keep publishing the data to automation component B. And here we have a unidirectional connection. There is no data or heartbeat going on in the other direction. So just output data is being published to automation component B. And in addition to these, since the FX itself is based on pub-sub communication model, so there can be a connection where the automation component is just publishing anonymously, and then there can be a automation component which is simply subscribing anonymously to published data by other automation components. So these are all the different types of data flows and connections that are possible. So here, this is a little more detailed view of how the connection is established and what are all the different things that are involved in the connection establishment. Just for a second, if we only focus on the upper part of the image, we have server A. It has an automation component A, and then there is a functional entity A inside in it. It has an endpoint A, and it has a publisher and subscriber, and similarly on the server B. So here we are looking at a single connection where the endpoint A is publishing data to the subscriber on endpoint B, and as well as endpoint B is publishing to the subscriber on endpoint A. So to establish this connection, what kind of configuration is required and what are all the different configuration parameters that are uh, part of the connection configuration, which is consumed by the connection manager, and by calling established connections with appropriate information to both the automation component. It will have the connection established and the data going. So here you can see in this example, we have a single connection here, and in the connection configuration set, so it has a single connection configuration, and this has two endpoints, one endpoint from automation component A, and then the other one is from the automation component B. And there is a pub/sub model as well. So this defines how the pub/sub communication from endpoint A to endpoint B is going to be configured uh, and published. And similarly, for the other direction as well, there is a pub/sub model for publishing the data from endpoint B to endpoint A. And for both sides, there is again a subscriber configuration type as well. And for both directions, there is a pub/sub communication flow configuration as well, which defines the flow of data from endpoint A to B and the other side B to A. So with all these configuration parameters starting from endpoint to the functional entity and to the automation component and to the server. So all of this data is part of a single connection configuration, and the connection configuration set will have several such connection configuration types and their instances with all the data filled in. And when the specific connection need to be established, connection manager picks up this connection configuration type data and uses it to call established connections method on server A and server B, which will internally establish the connection and will start the publishing and subscribing going. So from the network perspective, how does this look once the connection is established? So the connection is established between automation component A and B in this example, and we have a subscriber and publisher on both sides. The subscriber have dataset reader, and of course the publisher have dataset writer. Similarly, on the other side as well. So this is in this example, this is a bidirectional connection where the data is being exchanged over a unicast UADP UDP messages. So here writer group writes the data, and then the subscriber receives it on its port and then consumes it and then propagates it and maps to the corresponding nodes on the OPCUA address space. Similarly in the other direction as well. So here to the specific IP address and port, the data is sent over UDP or over raw Ethernet using a specific MAC address. So here we are looking at multiple connections, but again, these are again based on unicast. So here you can see there's a connection going on here and there's a connection going on here. Corresponding to these connections, there are unicast publishing and subscribing happening from both sides. So here, this writer group is publishing and to to both of the unicast addresses here, and they are consumed. And here also again, this writer group is publishing to two of the unicast addresses here, and they are subscribing. So this is again multiple connections, but again based on the same unicast concept. So here in this example, we see multiple connections where unicast and multicast both are working together. This is again, we have 4 different connections where for one connection, the unicast messaging is going on between automation controller B and then A, and then the another unicast connection between automation component A and C. And we can also see a multicast connection going on between automation component A and B and C. So here in the multicast case, the automation component will join a multicast group to receive the messages from a specific multicast address so that they can consume it and receive it and consume the data. So with respect to security of the OPCUA FX, so here the OPCUA FX, OPCUA security itself is already established with respect to authentication, authorization, and role-based access to specific nodes, and then specific permissions to specific role-based users, and so on. And also there are well-established security policies where the messages are either signed or the entire message is signed and encrypted on both sides, and so on. So the same security infrastructure and the security specification is extended to PubSub communication and as well as OPCUA FX. So your existing security infrastructure for your OPC applications will be useful when you are extending the same specification to same security to OPCUA FX as well. There is this additional interaction required between the connection manager and security key servers. There's a entire part of OPCUA specification on security, which will have all the details. So, but for today, we are only going to look at how the existing OPCUA security interactions are adapted for OPCUA FX so that the FX communication themselves become secure under the same security policies and the endpoint security that has been adopted for that specific OPCUA server implementation. So here we have connection manager and 2 automation components, and the connection manager is trying to establish connection between these 2 automation components. So here the SKS is there. So The connection manager sends add security group request to SKS, and then SKS adds that security group, and in response sends the information about the security group that it has created and added. And then the pub sub connection info itself is again set up with the SKS, and SKS updates the group info and sends back. And then connection manager sends the request to set up the publisher on the automation component. And then the automation component responds back with its own IDs. And then SKS sets the security keys with the automation component, which needs to be used for all the further communication. And then same set of exchanges happens between the second automation component and as well as the connection manager and the SKS. So with this, the exchange of security keys and IDs and everything is done. So from that moment onwards, using those security keys, all the OPC specific security policies are executed and applied on the data exchange. So here again, the entire message can be either signed or signed and encrypted, and so on. So with this, we have come to the end of today's session. If you have any questions, please leave the questions in the LinkedIn event group comments, and we will answer those questions in the LinkedIn group event comments. And as an ongoing effort to bring the awareness of the OPCUA FX related technologies and all the other supporting technologies for the OPCUA FX, we will keep doing these webinars every alternative week possibly. And on this platform, we are collaborating with multiple OEMs and other member companies who are interested in building awareness on this technology. So with that, we have a next part of this series of webinars, part 7 on March 13th. The speaker is Lucas from Belden. He's a senior technology architect. He's going to talk about networking and how performance can be achieved on OPCUA FX based networks. So Belden, as you are aware of, a very strong has a very strong portfolio of network based solutions in the industrial Ethernet and in TSN. And the registration link will be posted soon so that you can register for this event as well. Thank you for joining us today, and please do join the LinkedIn group, and as well as keep visiting our YouTube channel for interesting content. And we'll be posting different different technological articles and demos and other content interesting to OPCUA FX specification and the how do we implement, how do you adopt this technology from end user point of view or even OEM point of view, and any advancements that are happening on this technology. We will keep updating our content, and we'll be posting new content regularly. So join the group and register for the webinar so that you can keep yourself up to date on what's